In today's video, I'm going to go through the step-by-step process I took to convert this small, unused closet in my basement into a finished electric sauna. I'll go through all of the steps, including demoing, putting up a vapor barrier, putting up the wood paneling, installing the electric heater, and finally putting together and installing benches and all of the finishing touches required to complete the space. By the end of the video, you should have a good idea what it might take to do the same thing for yourself if you happen to be interested in doing something similar. Okay, so time to get started. The first step of this process was to remove the drywall and all of the finishes that were in the existing space. Because the sauna is a wet environment, drywall is not going to last very long, and a lot of the electrical, including the outlets, were not protected, nor would you want them in a completed sauna. So what I did was I grabbed the hammer and I started swinging, pulled out all the drywall, removed the drywall screws, and got everything back to a rough state with just the studs exposed. Because the design that I'm working off includes floating benches, what I decided to do was put in what's called blocking in the wall. These are small horizontal pieces that you put in between studs, and they allow you to have a large and strong landing zone for the eventual screws that you'll need to use to support the benches. I'll show a photo here of what I'm talking about, but as you can see, because there's no vertical supports attached to the benches, they're going to rely on the framing of the wall to support the weight of whomever will be sitting on them. Once the blocking was in, it's time to start installing insulation. For this build, I decided to use rock wool insulation. I found that this was recommended highly online in sauna building communities, and so that's the reason why I chose to go with it. I found the material is fairly easy to work with, and all it requires is a manual saw, like a drywall saw or something similar, to cut it roughly to the size of the openings that you need to place it into. So I went through, I used 5 bundles of rock wool insulation, and I filled all of the wall cavities and the ceiling cavity as well. I tried to do this as tightly as possible so that the insulation in the space didn't have any gaps, so that the performance of the electric heater was sufficient and would keep the space as warm as possible. Okay, so now for one of the most important steps, and also one of the steps that's most easily overlooked, and that's the vapor barrier. A sauna is considered a wet space, especially a sauna where people are pouring water onto the rocks in order to create steam, which is quite common. This steam and excess vapor in the area can cause a lot of problems with your framing over time. It can also rot out the wood paneling in your walls. The vapor barrier I used is like an industrial tin foil. It's really thick, it's impermeable by water, and all of the seams are sealed with a tape that keeps any vapor from escaping from inside the sauna to in the wall of your build. This is extremely important, especially in an interior build, because the last thing you want is regular water getting into the framing of your house and starting to cause a problem with rotting and mold. So once you've sealed up the space with the vapor barrier, the next step is strapping. Strapping kind of works in conjunction with the vapor barrier in order to manage all of the excess steam that's in the air during your sauna use. The strapping goes on the wall. The stuff that I used was about a ½ inch thick. And what this does is it allows for a little bit of an air gap between the vapor barrier and the paneling. What happens with the steam in the room is that it condenses on the vapor barrier, and if there's no space, it kind of gets trapped back there. What the strapping does is it allows for that airspace, so the water that condenses on the vapor barrier can escape the space, and that way it's going to keep it nice and dry. As a side note, I used brad nails, finish nails, and screws for the installation of all of the wood in this project. And for each of those fasteners, I chose a 3/16 stainless steel material because the space is so wet, I didn't want to have to deal with corrosion of fasteners causing rust runs and other discolorations after a long time of use. For this build, I chose to use a 6,000 watt electric heater. I chose this size by using online calculators that help you to determine the heat loss of your space, as well as the interior volume, and calculate the size of the heater and how long it'll take for that heater to heat up the space. I would highly recommend considering using an electrician for this step unless you have a lot of prior electrical experience. Personally, I chose to use an electrician to do all of the installation because it's extremely important that the wiring and breaker are sized correctly. I also wanted to make sure that the fittings inside the sauna connecting the heater to the wiring were watertight and done correctly. This is super critical since you're going to be dumping water on this heater in the future, and you want to make sure that everything was done correctly and is watertight. So the heater size that I chose was the 6,000 watt unit. You'll find that 6 and 8 kilowatt units are the most common sizes for electrical heaters. These tend to cover the majority of sauna sizes, unless if your sauna is way larger or way smaller than what I built, you might find that you need something that's outside of this size range. The heater I chose to use came from a brand called Harvia. It's one of their more basic units. The model is the KIP, and it has some basic controls on the bottom that you can adjust for a timer and then set the temperature you want for the space. I found that this model's pretty simple and it's worked quite well. Okay, now on to the exciting part, installing the wood paneling on the walls and the ceiling. For this step of the process, I chose to use 4-inch tongue and groove paneling in cypress material. Now, there's a lot of talk online about what type of wood is preferred for the interior of the sauna. And in North America, a lot of people choose to use cedar, and there's nothing wrong with it. That being said, you don't have to use cedar, and depending on where you're from and what your budget looks like, you may choose to use it or to use something else similar that'll perform just as well. In my area, cedar was incredibly expensive, and for that reason, I chose to use an alternative. Some of the options available in addition to cedar are cypress, pine, spruce, alder, or really any other soft wood that's relatively clear of knots and doesn't have a lot of sap. It's really important that you use a tongue and groove profile or something similar in order to help keep the boards in alignment as they cycle through the extreme temperature and humidity changes that they'll be susceptible to in a sauna environment. So the tongue will basically go and stick into the groove of the adjoining board. And what this does is it fastens it in a horizontal alignment so that if it warps a little bit, it doesn't become immediately noticeable with a gap opening. When it came to building my benches, I wanted to make sure that they were strong, and I also wanted to hide all of the fasteners from the surface of the bench. So for this reason, I chose to use 2x4 framing and screws which were attached from the bottom. So I had to design the frame so that the screws could come in from the bottom without penetrating through the top of the wood. And what I did here was I chose a screw that was just a little bit shorter than the total assembly of the frame and the top board. This way I could screw in from the base without penetrating through the top of the wood. The reason I chose to hide the fasteners is because I wanted to make sure that you wouldn't accidentally bump up against a piece of metal while you're in the sauna. Because it's so hot in there, anything that's metal that you lean against is extremely hot and can cause burns. I found sourcing a sauna door to be quite difficult. The reason for this is that it's pretty specific to the application. There tends to be two types of doors used. The first one is just a tempered glass panel, which is actually pretty similar to what you would use in a glass shower surround. The other type of door is a hardwood door. Often they're made out of cedar. I ended up going with a door with a hardwood surround and a glass panel in the center.
Overall, I'm really happy with how this build turned out. It's been awesome having access to a sauna in my house especially at the end of a busy day. I hope this video is useful for any of you who may decide to work on a project like this in the future. If you made it this far and you enjoyed the video, please give it a like and let me know in the comments if you end up building a sauna for yourself at home. I'd like to hear how it all turns out. Cheers.